Lesson 8-3 is when we're going to start talking about scatter plots, and this is the meat of the chapter statistics. A scatter plot simply is a bivariate data set. Bi means two. Variate is two different variables. It's observations on two variables. For example, you might collect data on 13 different car models. Each observation would consist of an X and Y pair. So we're going to say X is how heavy the car weighs, and Y is how efficient it is in fuel. So the table below shows this. Here's the model of the cars. They are cars manufactured by Chevy in 2009. Doesn't say what kind of cars they are, it just tells us the weight of the car, which is the X value, which I got from reading up top, and the fuel efficiency of that car, meaning how many miles it can go on 1 gallon, is Y. So in the table above, the observation corresponding to model 1, right here, row 1, is 3200, 23. What is the fuel efficiency of this car? That's the Y value. So fuel efficiency of this car is 23 miles per gallon. And next it asks about the weight, which is the X value, 3,200 pounds. So I use that table, and that gives me an X and Y coordinate ordered pair, which really means how efficient it is on fuel compared to its weight. Add the points to the corresponding other 12 observations in the scatter plot. So what I'm going to do is I'm going to go down here. This is kind of hard to read because it's pretty tight in the coordinate plane. We'll do the best we can though. And all you do is you put dots where they fall. So number 1 is done for us, 3,223. The second one is 2550. These go up by 50, so this is 2550 and 28, so I go up. Here's 25, 26, 27, 28. I put a dot here. The number 3 is 4,050 and 19. So this is probably the hard part of putting this together. So in order to take up time of just me doing this, what I'm going to do is I'm going to pause the video, keep adding the dots, and when we come back on, I'll have the dots done for you. I apologize, I can't do that. When I paused it, there was a screen right in the middle and it wouldn't let me continue filling this in. So I'll have to do it on the screen as we go. Sorry about that. Next one is 4,050 and 20. So it's the same line, just up one. 3,750 is here. And it's up to 20. So like I said, this is probably the tedious part of the whole thing. 3,550 and 22. Same one, but 19. Those are kind of easy to do and works out like that. 3,525. 4,616. And if I misplace one of the dots, I apologize. 5,250 and 12. There's 5,250. $5,616. $4,516. And last one, 4,815. So this is the scatter plot. There should be 13 dots. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. That's weighted. Make sure you have them all. 23, question 23, do you notice a pattern in the scatter plot? If you kind of look at this, it seems like they're all kind of going down in a straight line. So, yes, there is a pattern, and it is a negative, and we know that because it goes down, negative relationship. What does this imply about the relationship between the weight and the fuel efficiency? As the weight increases, meaning as the cars get heavier, it looks like by using the scatter plot, the fuel efficiency decreases. So as one goes up, the other goes down. That's a negative relationship. If we turn to the next page, there's another chart here that talks about the price of shoes and the Consumer Reports quality rating, meaning how good they are. The quality rating is a scale of 0 to 100, 100 being a very good quality shoe, and the price being in dollars. So 24, as one observation, the data set 1, 10, and 57. So price is X, quality is Y. What does this order pair represent in terms of cost and quality? So cost of $110 has a quality rating of 57. It's kind of expensive for not that great quality of a shoe. To construct a scatter plot of this data, you need to start thinking about appropriate scales for the axes of the scatter plot, meaning what numbers are they going to show. The prices in the data set range from 30 to 110. So we have 30 is the cheapest, 110 is the most expensive. So a reasonable choice for the scale of the x-axis would be from 20 to 120. You don't ever want to start where the data is, and you want to go above the data. What would be a reasonable choice for a scale for the y-axis? So my smallest number in the y-axis is a 51, and I want to start below that. So I'm going to say 50, and it goes up to 71. So 10s are usually easiest. I'm going to go from 50 to 80. So the next thing I do is I count how many boxes I have to go by. So starting at 0, I'm going to count how many boxes there are going up. I have 31 boxes. 31 boxes. Keep that in mind. So if I go by ones, I will need 30 boxes, which is exactly what I want. So I'm going to start at 50. Now if we're starting at 50, that means we need to use a break line in our graph, which they did on the bottom. If you notice, it's that like lightning bolt, which tells you that the graph is not starting at 0. It's going to skip some in between there. And I'm going to go up to 80 by ones, which will make this a nice, easy graph to use. So I put my break line in here. This one is 50. Right in here is 60. Sorry, the words are there. This one here, which is hard to see on this, is 70. And it actually goes up to 79, which is still high enough for us to use. So the next thing I do, it says to construct the scatter plot. So I'm going to do that. It'll be a little easier. $65 is a rating of 71. $45 is 70. 45 is 62. 80 is 59. So you see, the bigger the numbers are, the easier it kind of is. 110 and 58. 110 and 57. 30 and 56. 80 and 52. At this point, if you want to just fast forward the video and you're comfortable filling this in, that would be okay too. 110 and 51 and 70 and 51. So this is our scatter plot. Do you see any pattern in the scatter plot indicating there's a relationship between the price and quality rating for athletic shoes? There's not really a trend here. It kind of goes across maybe. So no, there is no relationship between price and quality. Some people think that if shoes have a high price, they must be of high quality. How would you respond? There is no correlation between how much you pay and how good the shoe is. Don't waste your money. So this tells us what I've known forever, that most of the time you're paying for a shoe because of its name brand. On the next page, there's a question here. A pattern in a scatter plot indicates the value of one variable tend to vary in a predictable way as the values of the other change. This is called a statistical relationship. In the fuel efficiency in the car weight example, fuel efficiency tended to decrease as the car weight increased. This is useful information, but be careful not to jump to conclusions that increasing the weight of a car causes the fuel efficiency to go down. So that's true, there is a relationship, but we're not sure exactly what it's from. There may be some other explanation for this. For example, heavier cars also usually have bigger engines, and bigger engines are less efficient. So just because the weight increases doesn't mean that the car is more fuel efficient. There's reasons behind that fuel efficiency. In the next two questions, we're using the data. They collected information from 30 elementary school students on their shoe size and how well they read. So I'd like you to look at this and just answer the couple questions and see if you can come up with a reason about those. What we talked about, there's a scatter plot. A scatter plot is a data on two variables. Sometimes a pattern exists in a scatter plot. If the two variables exist in a predictable way, there is a statistical relationship between those two. Just because there's a statistical relationship between those two variables does not mean that they're a cause and effect relationship. Try those two questions, see how well you do, and bring those to class.